Thank you. And I want to thank the conveners for allowing me to share the results of my master's research with you. Today I will be discussing how the Asian monsoon, specifically the Indian monsoon, is linked to intermediate water variability in the Bay of Bengal during the last glacial period. So the diagram on the upper right shows how the Asian monsoon is a primarily temperature-driven climate system where heating in the summer causes large amounts of rainfall over the land, and that rainfall is then channeled into rivers which reach the ocean, causing this low salinity surface layer in the Bay of Bengal, which is where my samples come from. And you can see the impact on salinity in the lower diagram there. Because the rainfall is low in delta 018, you can use the delta 018 of surface dwelling forams as a proxy for monsoon intensity. I'm far from the first person to have done this, so here are two records, one from the Bay of Bengal and one from the Arabian Sea, which use this method for monsoon reconstruction. And so I have it plotted through the latter half of the last glacial period, from 60 to 20,000 years ago. And I also included the ice core records from both Greenland and Antarctica. Greenland on top, Antarctica on the bottom. And both of these records come to the same conclusion, along with many other records such as speleothems, that when you have warming over Greenland, you have a more intense monsoon, and cold over Greenland, you have drier conditions. But I will point out the difficulty in capturing this short timescale variability in sediment records. You see the same issue in my own results as well, that the signal is much broader. So for this reason, I'm going to leave the ice core records on the screen from 60 to 20,000 years every time. So you can use that as kind of a time anchor when I bring up various other records for comparison. So let's shift gears a bit to look at some benthic records. So here are two records. They're both from the Arabian Sea, one showing nitrogen isotopes which vary with denitrification, and the other showing total organic carbon. And you can see the signals are very similar to the monsoon signal that I showed on the last slide, as well as looking very similar to the Greenland ice cores. So one way you can interpret these records is it's just responses to productivity from monsoon-driven upwelling. However, a few other studies, such as Pitchevin and Boning and Bard, suggest that these records, or at least can partly be explained instead by intermediate water variability. So if you have more ventilation of the Arabian Sea, you're affecting the oxygen minimum zone that's present there. And so you would be affecting denitrification rates or the preservation of the carbon. I guess discussion is ongoing, but the water source that would be implicated for this increased ventilation would be Antarctic Intermediate Water, which I guess a lot of people are talking about here today. So Antarctic Intermediate Water is thought to have varied in intensity throughout the last glacial, as shown by the sediment core record from south of New Zealand, which is in the location where Antarctic Intermediate Water is getting formed. And the peaks in the delta C13 of this record suggests that there's increased ventilation along with warming in Antarctica. And I guess a similar structure to stable isotope record has also been identified in a sediment core off the coast of Somalia. And these authors suggest that their delta C13 record could be interpreted as intrusions of Antarctic Intermediate Water into the northern Indian Ocean. Well, let's take a look at what that would mean for this part of the world. So here's a salinity transect through the Indian Ocean and through the Arabian Sea. And you can see that low salinity tongue of Antarctic Intermediate Water does not really reach past the equator in the modern ocean. So those who invoke Antarctic Intermediate Water as an explanation for the benthic records in the Arabian Sea are suggesting a very different ocean than the one seen today. I also have labeled on here my core site. 19B at 1,400 meters depth. So I guess I wanted to test whether the geochemical signatures present at my core site allowed for the possibility of Antarctic intermediate water intruding into the northern Indian Ocean during the last glacial. So my strategy was to take both a planktic and a benthic record and see how the variations in the planktic record and the monsoon record were related to variability in the benthic record. So to do that, I measured some nutrient proxies. So you can see here that my core site is very high in nutrients in modern times. So I took a few cadmium analyses from H. elegans as well as a time series of delta C13 from C. pachyderma. And right, so I guess you can see that my core site is very high in nutrients, so high in phosphate and cadmium and low in delta C13. In modern times. My planktic record, so here's my core site again in map view. I measured magnesium calcium as a temperature control, as well as the delta O18 of G. Ruber, and you can combine these to get at the delta O18 of the surface water, which varies with the intensity of the monsoon. Okay, so here are my planktic results. And you can, I guess, they look pretty similar to the results I showed earlier, where there's a very broad signal, but the events present roughly match the events from the other records I showed in the area. And here is my benthic C13 record, and you can see that I guess, the record is punctuated by these higher delta C13 events on a millennial scale. So the beauty of getting your planktic and benthic records from the same core is that regardless of your age model, you can test you can test the relationship between the two time series. It's always internally consistent. So I've detrended each of those and plotted their residuals against each other, and you can clearly see that the benthic and planktic records are linked. So I have the axis reversed here for the delta O18, so it's showing that when you have a weaker monsoon, you have younger waters present in the benthic site, and when you have a strong monsoon, you have higher nutrient or older waters. Another student at UNH, Steve Phillips, he looked at some productivity records in the same core, and productivity seems to be roughly constant during this time. So we don't think that the benthic C13 record is influenced by local productivity, but rather by like a broader scale circulation change. Additionally, you can see that the benthics lead the planktics for most of these events. The correlation is highest when you correct for a planktic lag of 320 years. And if you consider that the changes in circulation would be fairly distant from this source, it seems that the changes in circulation are initiated much earlier than the changes in the monsoon. So I also am comparing my benthic record to the regional records, and you can see, well, the events do sort of roughly line up. The values are very similar to the sediment core from the Somalian coast. And, well, there's a bit of offset in the timing, but this is expected because we have tuned to different age models. So if you do interpret the Somalian core site as showing intrusions of Antarctic intermediate water, you could logically extend that to 19 degrees north in the Bay of Bengal. I guess it's not conclusive that that's what is occurring, but it's at least consistent with the idea. So I also measured a few cadmium data, and Okay, so you can take cadmium and delta C13. If you have them both, you can sort of create a nutrient signature of your water mass. As a water mass ages, it will become enriched in cadmium and depleted in delta C13. So the water mass signature on this kind of figure would move along to the lower right as it got older. And so here, okay, I have Atlantic intermediate water. Atlantic equilibrated Antarctic intermediate water, the blue crosses. And this is from a study off the Brazilian margin and during the last glacial maximum. And they found that there's sort of an offset from the surrounding North Atlantic intermediate water or deep water that's present there at the time. And my results, I guess, fall along an aging path of that same nutrient signature. So it's consistent with the interpretation of an aged Antarctic intermediate water source at my core site. But it's really not conclusive because there's not any cadmium data from Indian deep water near my site or from Red Sea water, which are the other two water masses that could be affecting my site. In modern times, Indian deep water has a lot higher cadmium content, as the transects kind of showed, and Red Sea water is also really high in cadmium. So these values would have been very different through the last glacial, but it's an area for future research so we can better constrain what those nutrient signatures might have been. So yes, it is consistent with, but not really conclusive of an Antarctic intermediate water interpretation. Thank you. I'm happy to take any questions.
We have time for a couple questions.
Thanks. Maybe I missed this. How did you get the OAT in the seawater?
Oh, yeah. So, can I flip back? Yeah, I took magnesium, calcium for temperature. Oh, and I also did the stable isotopes of the forams. So, yeah.